Biconditional. What's the prefix for biconditional? What's mine?
Five,
Two.
two.
Okay. So two conditionals. That's what we're talking about today. And then how that relates to what definitions are and how we can treat and deal with definitions. First thing, so let's talk about this. As you move through this course, in this textbook, it kind of explained to you how a lot of things in this class are presented. Let me zoom through to stop. Let's go to like section 3.2 here. Okay, so don't worry about what is being stated in here. But this isn't a theorem. This is just a rule throughout the class. You're going to get the theorems are just basically rules for us right now that we can prove that they're true. And we'll talk about how to do that later on. But this one says, if a transversal intersects two parallel lines, then alternate interior angles are congruent, right? Yeah. How was that presented to us? And what kind of phrase? If then. Okay. I go to another slide, and I get another rule. How's that rule presented to you? If then. Okay. If I go to, should be some more note.
Like PQ statements?
There's no, yes, there if then statements or P then Q statements.
Why are Q and P? I got a question. Is that why people say mind your P's and Q's?
No.
Mind your this and
So if, and then a statement, comma, then, and another statement, right? And the first statement is your hypothesis, and that's what we want to kind of think about in our mind is having a picture that is happening. So right now, if I read that, it says if a transversal intersects two parallel lines. So I need a transversal, you don't know what that is yet. If I need two parallel lines, I need those things to be intersecting, right? If I know that's happening, this is the result that I get from that. Okay? And that's what shows up in the then part. Okay?
Two parallel lines, how are they going to be intersecting?
A transversal is a third line. We'll talk about that all when we get there. But what I want you to see is that in chapter 3, you get if-then statements. We get to chapter 4, we get if-then statements. We get chapter 5, if-then statements. Chapter 7, if-then statements. Okay? Every rule that we learn through mathematics is provided if this is happening, if you're dealing with something like this, and this is the conclusion, this is the result that you get from it. Okay? So what I want you guys to understand is that we're trying to basically develop a way of learning how to read math concepts, okay, that are presented to us in text. That being said, our textbook does things a little bit differently. They start talking about these things called biconditionals today, okay, which is the way most textbooks after this course will write rules. Okay, when you see a rule written as an if-then statement, they do not imply, they do not want you to think that you can find its converse and it be true. Okay? So when they say if a transversal intersects two parallel lines, then same-side interior angles are supplementary, they want you to read that and say, that is the only way that I can interpret that phrase. It's true, because it's a theorem, they're giving it to me, so it is true. That's the only way I can interpret it. I do not want to come up with one of the 4 or 3 phrases that we came up with yesterday and say that they are true as well. And what a lot of people want to do is they want to reverse it. They want to say if same-side interior angles are supplementary, then a transversal intersects two parallel lines. See, I reversed it. Okay. They're saying if it's in the textbook written this way, the first time you see it, you do not want to interpret it as being able to be reversed. Okay. People get in trouble doing it. You've all heard the phrase, like if it is a square, then it's a rectangle, right?
Yeah.
And then people want to reverse that and say, well, if it's a rectangle, then it's a square, right?
Yes.
And you can't do that, all right? And we'll talk about why you can't do that here in a little bit. When something's presented to you in a textbook, a publisher, a website, some author that has some credentials, okay? I don't want you to get on a website because, Carter can make a math website, right?
Oh, yeah.
Okay, so I don't know that. I'm saying he'd be wrong, but I'm not sure we want to go and take all of his remarks on that website as truth.
Should yours? Yeah.
No, I'm not saying mine are either. Okay? But a textbook that has been like peer reviewed as a bunch of authors and stuff like that, they want you to refer to it as if, then. That's the only way you can see it. It's the only way you want to think about it. Does that make sense? Do not reverse it. Okay? The way our textbook works is if they want us to reverse it, This was section 3.1 and section 3.2. They're going to present to us the reverse version, the converses of it, and then we're going to learn that those are true as well. Does that make sense? Okay. But most textbooks don't do that. An Algebra 2 textbook doesn't do that. A calculus textbook doesn't do that. So when you get to those courses, it's going to be important how I can read particular phrases and understand all the information that that phrase is giving me. So yesterday we talked about if you see it as an if-then statement, that's the only way you can interpret it. Now we get what we call biconditionals. You said that's two conditionals. We're going to wrap them together. We're going to put them into one phrase. So a biconditional is a single true statement that combines a true conditional and its true converse. Okay? Conditional is just an if-then statement. That's another way of identifying it. Biconditionals are written by joining the two parts of each conditional with the phrase if and only. So now we're going to take the hypothesis of the original conditional statement and the conclusion of the original conditional statement. And instead of connecting them with the words if and then, we're going to connect them with the words if and only. Okay? Yesterday, the if word was an identifier for the hypothesis. I told you that's kind of the picture you want to have in your mind. That's the situation that's occurring in front of you. And then the then part is the conclusion. The then part is the result that you gain from that. Okay? With if and only if, those 5 words, 4 words, okay? 4 words, if and only if, those 4 words are identifiers to tell you this is a specific type of conditional statement. Okay? And there's 2 things that you can gain from this type of conditional statement. Okay? So here's what we're going to kind of create a biconditional from this information here. So I want you to take a minute, write down, if I look at this blue statement, if the sum of the measures 2 angles is 180, and the 2 angles are supplementary, I want you to write down the converse of that phrase. Okay? So in your notes, write that down. What's that? Yep.
Okay. I don't know. I didn't pay attention to math last year either.
2.39.
Wow. It's low.
That's your homework. It'd be probably...
I did it, I just never
Hey, well, that means you didn't do it. Alright, so, the hope is that the converse that you guys develop, I'm freeze this real quick, should look something like that, right? This is my true conditional statement. The converse is flip-flopping the if and then, right? Okay? So, those of you that may be still confused with that, if I were to take... If I were to take that part right there, come on, let me write. Okay, stop. That part, okay, that is the hypothesis. And when I do the converse, it is going to go in the spot or the location of the conclusion. Okay, then this is my conclusion, and it's going to go right there for my converse. All right? So identify your hypothesis and conclusion, and then flip-flop them to create converse. Is that doable? Okay. Would you argue that the converse there, if 2 angles are supplementary, then the sum of the measures is 180? Is that true or false? Sure. That's true. Okay. So right now we got a true conditional here. Okay. True conditional there, and we have a true converse. So what we can do is we can rewrite those as what we call a biconditional. Think about as an author, or if you're just writing this by hand, okay? That's kind of a pain in the butt to write both those phrases up there, right? If we could condense that down to one phrase that has less words in it, but still has the exact same meaning that those 2 phrases encapsulate, that would be much better, right?
Yeah.
Okay. If I'm writing something to an audience, okay? Let's say I'm writing a math paper to an audience. I'm probably going to write that to an audience of my peers, right? So I'm going to write it to other math people. Well, I'm going to use knowledge, information, and terminology, and notation, and grammar that those other math people would know, right? Okay. So if I write it this way, to a a high school level math teacher or a college level math teacher, they're going to think, well, this guy is writing to me. I'm in his audience. He's writing to me, and he's writing in a really dumb manner. That makes sense? He's dumbing things down for me, and that might insult the audience. Does that make sense? Okay. So as an author, maybe I wouldn't want to do that. Okay. Think about a publisher. I would not want my author to write this statement here, and then also have to write that statement there, because he uses more ink, he uses more paper, and that eventually, for me as a publisher, makes my book more what?
Shitty. Slappish.
Expensive. Okay. So I want to be able to condense things. Okay. So we have what we call biconditionals, and that's going to allow us to condense things. So what we do here, we're going to create the biconditional. It's extremely easy to create, but I want to make sure that we understand how we read it and interpret it. Okay? First thing you do is just choose one of these conditional statements that are true. They're both true, so it doesn't matter which one. Okay? So let's say I start with the one that's in blue. Okay? I'm going to first take out the word if. Okay? So I'm not going to worry about the word if here. I'm going to get rid of that. So I'm going to write the sum of the measures of two angles is 180. Now I'm going to get rid of the word then. But in place of the word then, I'm going to write if and only if. Okay? Is that doable for everybody? And then I finish the conditional statement. The two angles are supplementary. Okay? So that is my biconditional. Can I get all that in there? Okay? That is my biconditional that comes from that blue statement. Okay? And I can only create that because the blue statement was true, and then the converse of it was also true. So inside that statement, that biconditional I just wrote, is the fact of this thing here, and that blue statement, and this statement right there, is converse. Yes?
I thought you said it was less words.
Huh?
I thought you said it was less
It is less words. Count these words,
Yep.
and count all those words.
Together.
Together, it's more words than that one, right? Okay? Charlie? Yes. If and only if is it's a identifier to tell you what type of statement this is. Okay. When I see the words if and only if, it tells me right away that I can read this phrase: the sum of the measures of two angles is 180 if and only if the two angles are supplementary. So I can rewrite that as this blue phrase. But I can also, and that's read it left to right, correct? But if I read this right to left, two angles are supplementary if and only if the sum of the measures of the two angles is 180. That gets me the converse. Does that make sense? So when I read this blue phrase, it's an if-then statement, right? And it's in the textbook. It's written that way as an if-then statement. They want me to interpret that as that is the only way you can read it. You cannot reverse that phrase. All right? But in a textbook, if they write something with the words if and only if in it, now they're telling me you can reverse this phrase and you get a true statement when you do that. That make sense to everybody? Okay? So key phrases, key notation that tells us that we can interpret a statement multiple ways. And if and only if is that phrase. Now, you don't want to write it because it's too many words, right?
Yeah.
Okay? So, mathematically speaking, we're kind of lazy. Okay? That's why we have a lot of notations. We don't want to write things out. We want to be we want to say the most we can with the least amount of words we can. That's what a lot of math is about. The way the notation that we develop and all that kind of stuff. So this phrase, if and only if, I don't know why this thing's not working. If and only if can be abbreviated as IFF. Okay? And usually they're kind of italicized, cursive looking. So if you ever see that, it's not a typo, and it's trying to spell if, put the key down to them. It stands in for the phrase if and only if. Okay? And that's the question I asked you on test. What does the phrase IFF stand for? Or the notation IFF stand for? Okay? But that tells me that I really have two facts inside that statement. Okay? So they're going to ask you in some of your homework, can you build from two conditional statements that you know to be true, and they're converses of one another? Can you build a biconditional? Can you be more concise with the statement, save some, save some space in your writing, okay? Rewrite a phrase that is not as long, but still encapsulates the same two ideas that the two conditional statements encapsulate, okay? But what I think is more important is not necessarily going that route, but being able to read a biconditional and then take apart from that the two things that you get from it. Okay? Because that's what you're going to be asked to do when you move into like a calculus course or something above that. Is can I take a theorem, a rule they provide me, and know that I can reverse it? So a lot of people just see it one way. They see the way it's written, okay, read it left to right and say, oh, that's, if I start with this, then I get this. And they neglect that I can reverse it, and there's a whole nother way I can use that information. Okay. So here it says, what are two conditional statements that can that form this biconditional? Okay. So it says a ray is an angle bisector if and only if. Okay. So that phrase right there, the if and only if, is a huge identifier to tell me that there are two things that are making up this phrase. A ray is an angle bisector if and only if it divides an angle into two congruent angles. Okay? So the first thing we're going to do to write one of these conditional statements for that is that we are going to simply take the biconditional, put the word if in front of it. So if, and then a ray is an angle bisector. And now where I see the words if and only if, I'm going to replace them with the word then. It divides an angle into two congruent angles. If a ray is an angle bisector, then it divides an angle into two congruent angles. Does that make sense? Okay. That is one of the statements that we gain from this biconditional. But a biconditional, we know, is the collection of two true conditional statements that are converse to one another. So then the converse of that phrase, remembering that a converse is simply taking that part there. Let's see if I can change the colors. That part there. And that part there. And all we're going to do is switch their spots, right? We switch the hypothesis with the conclusion. So now I'm going to say if a ray divides an angle into two congruent angles, then it is an angle bisector. And because we know both of those phrases came from a biconditional, we know they're both true. Okay? And here's the idea. Here's the logic and why we would want to know this. And hopefully it makes some sense to you, at least with this example. If I gave you a picture here, let's say we've got maybe that set of angles and I call this, let's say, this is angle 1, and this is angle 2. Okay? What that biconditional is saying, it says a ray is an angle bisector if and only if it divides an angle into two congruent angles, right? Okay, we broke that down to two infinite statements. So this is the idea. If I tell you that you know that red angle, so that red ray is an angle bisector, what's it tell you about angles 1 and 2? Okay, they're congruent. They're the same, right? So it tells you that 1 and 2 are the same. So I started with the angle bisector, that ray being an angle bisector, and it tells me something about the angle, right? Because I'm able to, because I saw the if and only if in that phrase, and that tells me I can reverse the statement. Now, I can say, I'm going to tell you this. I'm going to tell you angle 1 is congruent to angle 2. what can you now tell me about the ray? That is an angle bisector. See how it's reversible? I started you with the angle bisector, you gave me something about the angles. Now I can start you with the angles, and you can tell me something about the ray. Okay? And in our geometry, and really in math in general, not every single rule is reversible like that. Only the ones that they want you to be able to reverse, the only ones that is able to be done in, are going to be phrased with the words if and only if inside. Is that all right with everyone?
Yeah.
Okay. I'll make sure we can do that.
Where was it? Someone closer.
Alright. Alright, so that leads us to talk a little bit about definitions. Okay? There are some qualities that all good definitions have. And remember why we have definitions. I've about this before. We want to be able to classify things, right? We want to be able to group things into appropriate categories. Okay? And we want to make sure that nothing in one category crosses over to another category, right? I mean, we don't want, we talked about how we don't want a zebra to be identified as a giraffe, something like that. Something pretty silly, right?
Yes, sir.
So 3 points there. A good definition uses clearly understood terms. Okay, so when we write a definition in this class, we're going to use terms that we have already defined. Does that make sense? I don't want to create something in which you have to look for and learn new vocabulary words. Okay, so the words that we use to define something should already be clearly defined or clearly understood. Okay, good definitions also. For instance, if I go to the Webster Dictionary, you're going to find some of the words in there are pretty poorly defined. You ever look up a word, look for a word, and maybe I'm in English class, I see a word I don't know, I go look it up, and inside that definition, it uses some derivative of that word.
You don't know what it means.
Yeah, you don't know what that word means anyway, so how are you going to know what the derivative of that word means? Okay? So it's kind of you get yourself in kind of an infinite loop where I'm never going to learn what that word is because of the way it's been defined. So we'll eliminate. We won't do that in geometry. Guys, push your around, please. Okay. A good definition is precise. Okay. Precise means that I can, if we're in chemistry, precise means I should be able to, if I'm measuring an amount of water, I should be able to get down to maybe the same milliliter every single time I measure. And I measure it 3 or 4 times. I get down to the same milliliter. Maybe I weigh some mass in chemistry, and I should be able to get down to the same hundredths of a gram every single time I weigh that thing. Does that make sense? Okay. So that's what preciseness means. For us in like English language and stuff like that, it eliminates vagueness. Okay. If I say large, okay, or sorta, or almost, okay, those are really vague words that aren't very good classifiers. If I say I'm close to Claire, okay, I am, but now I still am, right? Now I am still close to her, but now maybe I'm far away from her now. Where was the drawing point? Where's the line we drew in the sand that said this was close to her, this wasn't close to her? Does that make sense? Okay. So we want to eliminate that because that vagueness could actually put one thing in a category where it should have actually been defined somewhere else in a different category. Okay. So we want to eliminate words like that.
I wouldn't be right around. Yeah, you were. I fixed my con. I went to fix my contact. And next thing you know, someone hit me.
Yeah, but 5 minutes before that, yes, Mr. Fett. Yes, Mr. Fett.
Okay,
Yes, Mr. Fett.
I was just answering you. I don't know why they were laughing.
A good definition is reversible. Every good definition is reversible. And what that means is that every good definition can be written as a biconditional statement. Okay? Every good definition is reversible. Think about tests that you've taken in the past. Have you ever taken a vocabulary test and the definition is written out for you? And you had to match the vocabulary word, right? Okay. But you've also taken tests where they write the vocabulary word out, and you have to write by hand the definition, correct?
Yeah, there's something like makes like one to the front, and you have to write the word, and then the back have to write left.
Right. So that's a biconditional idea. If I give you the vocab word, you can provide me the definition. If I provide you the definition, you can give me the vocab word. Does that make sense? That's what we did with that last slide. This angle bisector. Okay, this is the definition of an angle bisector right here. Okay, if I say an angle bisector, and you can provide me the definition, you say it's a ray that cuts an angle of 2 parts. Okay, But if I give you the definition, I said this is a ray that divides an angle into two real parts. You should be able to say angle bisect. Does that make sense? Okay. So every definition we come across could be written that way. That's another quiz question that you'll see. I'll say every good definition can be written as a biconditional. Okay. What I want you guys to do on this one, just take a minute. You've got a conditional statement there. I want you to write the converse. I want you to determine if it's true or false. And if you got time before we reconvene, I want you to write what you think the biconditional will look like. Okay? Take a minute to do that. So hopefully you guys are getting to find the converse. Okay. Simply take this conditional statement, take the if part, take the then part, flip-flop. Okay. If two angles are complementary, then the sum of their measures is 90. Okay. Would you guys agree that that's a true statement?
Yeah.
Okay. So the original conditional is true. The converse is true. So now we want to write a biconditional. Remember, a biconditional, if these two things are true, it's frozen still. If these two phrases are both true, when you start your biconditional, it doesn't matter which one of those you start with. Okay? So I could write, I'm going to start the one up here in yellow.
Isn't it for as long as you write if and then?
Right. So I'm going to keep the same format. I'm going to get rid of the word if. I'm going to write the sum of the measures of two angles is 90 degrees. And now I'm going to put the phrase if and
Or just get IFF.
only if, okay, which yes is IFF. We'll do it that way, okay. And then I finish the conditional statement. So the angles are complementary.
Well, that's 4 words in that one.
Huh?
Oh, I guess.
But the idea is that we should be at that one there, however many words that is.
I forgot about the converse.
Maybe that's 25 words.
Yeah.
Okay? Well, if this one here is 20 words, and this one's 20 words, this one is less work than writing 40, right? Okay? The alternative biconditional you could have written. Okay, so when you have a conditional statement, it's converse that is always true. There's really 2 ways you could write the biconditional. Okay? Because if I got this, if I pull that apart, I get that phrase, and I get that phrase. Okay? If I write, and I got this biconditional by starting with this original conditional and just taking the if out and taking the in out, right? And replace it with an only. I could have also started with the converse. So if I start with the converse, I could say two angles are complementary if and only if the sum of their measures is 90. Okay? Because they're biconditionals, you can read it left to right and gain a true statement. Or you can read it right to left and gain a true statement, right? If I read those two biconditionals left to right and right to left for both of them, do I develop the exact same two true statements?
Yeah.
Okay? So when you're in your home and they ask you for a biconditional, I think in your home for the most part, they're going to have a lot of things written out for you, and you're just going to highlight and select which one's which. Okay? Either one of these could be fair game for a biconditional. So if you're doing this on like paper, you got a homework question and say, here are two true conditional statements, write a biconditional, and you write it out, and it doesn't match anything that's in your selections, reverse what you wrote and see if that shows up in your selections. That makes sense? Okay. But the reason I want you guys to understand this is because when we go throughout other math courses, okay, when I read something like this phrase right here, okay, this first one, okay, the sum of the measures of two angles is 90 if and only if the angles are complementary, that tells me two things. And I want to make sure that we don't read that and think it only tells me one thing. Okay? I see the words if and then, it tells me one thing. I see the words if and only if, it tells me two things. Okay? So this whole lecture, this whole discussion is about how we read particular statements. Okay, make sense? You guys remember in English class you talk about like declarative statements, you talk about
Yeah.
all that kind of stuff, right?
Yeah.
Like understood, used, and stuff like that. You what all those things are
You
called.
understand.
Yeah, what kind of you understand? What kind of declarative statements? What kind of other statements?
It's got the exclamation point.
Yeah. Well, but what are the other types of statements?
Declarative, imperative.
Imperative. Okay, so a lot of those things are the way they're structured tell you something about how you read it and how you interpret, right? The way these things are structured tell you how to interpret it, how to read it, how to use it. Okay, and it's very important as we go through other courses on what information is being gained from a statement that they provide us. I want you guys to. We're gonna jump to section 2.3 in your homework. Okay, so that'll be available. Actually, it should be available now, I think. If not, I'll open it. But you have about 8-9 minutes. You guys can work on it.
That's understandable.
Okay.